You've probably heard this one, right? The story about the penny dropped from a skyscraper? It's a classic urban legend, the kind of spooky story you'd hear on the playground. The whole idea that this tiny coin could turn into a deadly missile is, well, it's pretty terrifying. So today, we're going to dig in and find out if there's any truth to it at all.
So this is the big question, the one at the very heart of the legend. You can just picture it, this little copper coin, falling, somehow transforming into a lethal projectile aimed at some poor, unsuspecting person down below. But is that real physics or just a good story?
And yeah, this is the part that gives you the chills, the morbid punchline we all know. The thought that this everyday object, something you have jangling in your pocket, could get moving fast enough to be a deadly weapon. It sounds scarily possible, doesn't it?
Let's be real here. The myth just feels right. Our intuition tells us that the higher you drop something, the faster it goes and the harder it's going to hit. A penny from 10 feet? Okay, maybe it stings a little. But from over 1,000 feet, our brains just jump straight to catastrophe.
To really solve this mystery, we have to start with a little thought experiment. Let's imagine a perfect but totally impossible world. A world where we could drop that penny in a place with absolutely zero air, a complete vacuum. So in this perfect vacuum world, the only thing in the game is gravity. It's just pulling that penny down and there's nothing, absolutely nothing, pushing back to slow it down. It just keeps getting faster and faster for the entire fall.
And you know what? If that were actually the case, the math is just wow. That penny would slam into the ground at a staggering 193 miles per hour. That's faster than a Formula One race car. And at that speed, yeah, a penny would be seriously dangerous. But of course, the Empire State Building isn't on the moon.
Back here, on good old Earth, our little penny has to fight against a powerful, invisible enemy from the second it's released. It's a force that changes the entire equation, and that force is the air all around us.
You have to stop thinking of air as empty space. It's not. It's more like a thick, invisible soup of molecules. As that penny falls, it has to physically shove all those molecules out of the way. And guess what? They push right back. We call that push air resistance, or drag, and it's basically the planet's built-in speed limit.
So look, in a vacuum, gravity wins. No contest. But here, in our atmosphere, it's a constant battle, a tug of war. Gravity pulls down, air resistance pushes up. Eventually, those two forces balance each other out perfectly. The penny stops accelerating and it hits its top speed. That's what we call terminal velocity.
So how does this all play out for our actual penny? I mean, it's not a sleek bullet or a perfect sphere. It's a tiny, flat, lightweight little disc. And that shape? Well, that's its biggest problem. Literally, its downfall. A penny is basically the opposite of aerodynamic. It doesn't slice cleanly through the air. Instead, it wobbles and flutters and tumbles all over the place, kind of like a leaf falling from a tree. All that chaotic movement creates a massive amount of drag. It basically becomes its own tiny, terrible parachute.
With all that tumbling and air fighting against it, a penny's real top speed is only about 50 miles per hour. I mean, compare that to the 193 miles an hour in a vacuum. That's a huge difference. Heck, that's slower than a fastball in the major leagues.
Okay, but you might be thinking, hey, 50 miles an hour is still pretty fast. And you're not wrong. So, to really understand the danger, we have to look past the speed and check out the actual punch it's packing, the impact energy. And this is where the myth really falls apart. A falling penny has less than 1 joule of kinetic energy. To put that in perspective, a paintball, which stings but is pretty safe, has about 12 joules. A .22 bullet? Around 150. You see, the penny just doesn't have the oomph to be dangerous. It's not even in the same ballpark.
Now hold on. This does not mean falling objects from skyscrapers aren't dangerous. They absolutely are. The penny legend sticks around because it gets one thing right. The danger of height is very real. It just picks the completely wrong object to worry about.
So, forget the penny for a second. Imagine a half-inch steel bolt from a construction site. Now this thing is 40 times heavier, and it's way more aerodynamic, so it slices through the air instead of tumbling. That allows it to reach a terminal velocity 4 times higher than the penny.
So when you do the math, 40 times the mass and 4 times the speed, that steel bolt hits with over 640 times the kinetic energy of the penny. Now that is absolutely lethal, and that is why hard hats are mandatory on construction sites. They aren't worried about pennies, they're worried about bolts, wrenches, and rivets.
So we've crunched the numbers and looked at the physics. But what happens when you put this myth to a real-world test? Let's get the final verdict, once and for all.
Of course, the legendary team at Mythbusters decided to settle this question for good. Since they couldn't just drop pennies from the Empire State Building, they did the next best thing. They built a special gun to fire a penny at its exact terminal velocity.
And their results? They were totally conclusive. They fired the penny into ballistics gel, which is made to act like human tissue. The penny didn't even break the skin. It didn't leave so much as a chip on a simulated skull. The impact was, really, just a surface-level annoyance.
And for the final definitive proof, host Adam Savage bravely stood in the line of fire and let them shoot him with the penny. His one-word summary of the whole experience: it stung. That's it. Not lethal, not a skullcracker, it just stung.
And there we have it. The legend starts with an idea that feels right to all of us. More height equals more speed. But it totally ignores that hidden force of air resistance, which puts a hard limit on that speed. In the real world, it's an object's mass and its shape that really determine if it's a minor annoyance or a true danger.
So the case of the killer penny is officially closed. But it kind of leaves you with a cool question, doesn't it? What other things that we take for granted as obvious facts are actually just compelling myths waiting for a closer look? Something to think about. Thanks for joining me on this one.